So let's think for a moment about memory. If I'm this machine learning system, I have this model of the world, and you can think of it as an artificial neural network or something. So it's got a bunch of parameters, and I'm constantly modifying those parameters. But there's another kind of memory that would be very useful for me to have, and that is memory for specific events and the order in which they happened. So suppose I can do niche construction on the world. I can act on the world in a way that generates stability. If I can do that, then I can write some information in a little part of the world that I can rely on being there, right? I can rely on it being stable. So that's, for example, what I do in my lab notebook.
Right.
I write down what happened as a response to certain sorts of probings of the environment, for example. And that's a kind of memory. And in particular, it's Stigmergic memory. It's memory that I've written on my environment. And I can't be sure that it's not going to change, just in the same way that I can't be sure that, what I store in my neurons isn't going to change. But I can be pretty confident in it when I come across it again that, in fact, this sentence in my lab notebook is the one that I wrote on whatever date that was. So if I can do that, I can record memory for events by writing them on some stable part of my environment. Okay, now think about that process. If I'm writing on my environment, I'm acting, so I'm doing something that's thermodynamically irreversible as far as I'm concerned, right? The environment might change it, might erase my bit, but I'm not changing it. Okay, so it's thermodynamically irreversible as far as I'm concerned, which means I have to burn some energy to do it. And burning energy takes time. And in fact, I'm not going to be able to regard that as a memory unless it's time-stamped, because I won't know what order it got written in unless I've time-stamped it. So if I'm going to do this memory thing, I have to have a clock. I have to implement a clock internally. Because if it's out in the environment, it's just input to me.
Right.
But an internal clock, something that actually ticks for me, ticks whenever I write in this irreversible way on the environment. So memory and time go together. And we haven't said anything at all about 3D space. We've just constructed time. It's my clock, not something out there. And that's the fundamental time that one can construct in this theory. And if one then introduces communication between different systems along particular kinds of channels, then they can share clocks and things like that. But these internal reference frames are the most important and fundamental. And the first one that you have to construct is time. Now, how do you get space? Think about how human infants get space. They do motor babbling. They move their limbs around, things like that. Oh, this is mine, right?
That's right. That's right.
And I'm doing something. I'm exerting effort to see this visual pattern. So if you think of a system that is interacting with its environment, and on its boundary, it has certain areas of stability, then it can, in effect, associate areas of stability on its boundary in different ways. So if I have an area of stability here and an area of stability down here, then I can put them together or not, right? So here's a pattern on my shirt, and here's my hand. And I can put the hand near the pattern on my shirt or not. And for an infant, that's the beginning of the notion of space, of these coordinates that are in the world.
That's really cool.
And what are they? They're a way of making a correlation between different things that are islands of stability in the environment. And we can think of it all in terms of redundancy. You know, John Wheeler again said something along the lines of, there's time in the universe so that everything doesn't happen at once. There's temporal redundancy, right? Things can happen now and then they can happen later and they can happen later and the same thing can happen later, right? We have this idea of identity over time. And that's what the free energy principle is about preserving, right? Redundancy through time of system environment boundaries. But space is just a way to keep everything from happening on top of each other. So space is a way of allowing a thing to be here and then that same thing to be someplace else. And then that same thing to be someplace else. Right. So it's, again, it's something we use to allow things to have identity under various kinds of manipulations. And in fact, the kinds of manipulations are the manipulations in the Poincare group, right? Right. Yeah, I can move it from here to there, or I can turn it around, or something like that. Those are the manipulations that preserve identity for us.